Hello, 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 hello. So this question is about calculating beam reactions of a simply supported beam. And all a simply supported beam is just a bit of metal, right? Simply supported, so it's like on these 2 points by the look. I've called them A and B. It's not a roller, they're not moving, they're just simply supported A and B. So this is my beam. It's got 3 point loads. 3, count them, 1, 2, 3. A point load is a load coming straight down. So we've got 4, 6, and 8. 4 newtons, 6 newtons, and 8 newtons. Okay, you might have kilonewtons, you might have meganewtons, but I've got 4, 6, and 8 newtons. Point A, so my 4 newtons is 2 meters away from point A, which is important. My 6 newtons is 4 meters away from point A. My 8 newtons is 4, 5, 6, 7, 8 meters away. And the length of my beam is 2, 4, 8, 10 meters long. Handy. We've also got this thing called a UDL. And if you remember, a UDL stands for a uniformly distributed load, which can be something like the weight of the beam, because the beam's got a weight, a bit of metal's got a weight. It's all, so that green bit by there, like that green sort of line and lines in the middle, that's meant to be the UDL. And it's 0.9 newtons per meter. Okay, so the UDL is 0.9 newtons per meter. Hint, hint, 0.9 newtons per meter. And we've got 10 meters of it. So we've got 4 bits of things happening. We've got 3 point loads and 1 uniformly distributed load. And we've got to find reaction A and reaction B. Okay. First of all, we've got to convert this UDL into a point load. Because the 4, 6, and the 8 are point loads. This UDL is not a point load, but we can convert it into an equivalent point load, which is quite easy. So what we do is this. Let me get a pen for you. Let's go black for now. Let's see. There, 9. So we've got to convert UDL into point load. Not Premier League, point load. We've got to convert the UDL into a point load so we can use it. Now our point load is 0.9 newtons per meter. Okay, so that means it's 0.9, and we've got, how many meters have we got? How long is this UDL? It's acting across the beam, and the beam is 2, 4, 8, 10 meters long. So to convert it into equivalent, it does it by 10, because we've got 10 meters. 9 newtons. Right, that's the equivalent of the point load. And it acts, I'm going to put it halfway along. This UDL acts all across the beam. Some don't, right? But this one does. So I'm going to put it halfway, and halfway happens to be half of 10. It is 10 meters long beam, and half of 10 is 5. So I'm going to put this 9 newtons halfway along. So what I now get is this. I'll just quickly draw the beam for you. Because now we've got, so here's my beam like this. I'll just quickly draw it. Let's get a different color pen. So we've got now, what we've got here? We've got 4 newtons by there. We've got 6 as well. And we've got an 8 over there. And we've also got the UDL, which I'll put in a different color there somewhere. 9 newtons. So all I've done there is it's still 4, 6, and 8. Look, 4, 6, and 8. This 9 newtons now is in the middle. So this thing here now is 5 meters because my beam is 10 meters long. Okay, that's my point A there and point B. Look, same as before. So it's just a same drawing. Look, and what was it in there? It was 2 meters in there, wasn't it? And it was 2 meters in there. Between the 6 and the 8 was 4 meters. Okay, so make sure you get that. So it's 4 meters two-way, 6 is four-way, the 9 is halfway, and the 8 is 4, 5, 6, 7, 8 meters away. So that's our beam with my 4 point loads. Okay, I've converted the UDL into a point load so I can use it. Now I can calculate my beam reactions. And to do that, we're going to use this moment. A moment is force in newtons times distance. Okay. Force is in newtons and distance is in meters. So the unit of a moment is a Newton meter. If you're in America, somewhere like that, it might be different, but because distance over there, you might use inches. Okay. SI unit is force times distance, newtons times a meter. And I'm going to call clockwise positive. Okay. Some people call anti-clockwise positive, but it's my video. I'm going to call clockwise positive. So these are my assumptions. You can use them if you want to. And it's force times distance. I've also said as well that the sum of moments, because we've got to give it some sort of number, haven't we? Sum of moments equals 0. Because this beam is in balance. Right? So it's not moving up and down, it's not spinning, it's not twisting, it's in balance. Okay, so I'm going to make everything add up to 0. So the sum of the moments is 0. Those are my assumptions. You can write them down if you're doing an assignment, because we've got to assume something. So it's force times distance I'm doing. We start off with the first force, which is number 4. Okay, so different color thingy-majig. Let's go different color. Let's go this one here. So moment is force times distance. My first force is 4. How far is it from point A? Point B. Okay. Point A and point B. So we're going to be taking moments about point A. So moment is force times distance. My first force is 4 and my distance is 2. So I'm going to be doing this. 4 times by 2. Because I'm taking moments about point A. Moments about point A. A is my pivot point. Okay, so 4 times 2. I'm trying to find RB and RA. Okay, so I'm taking moments about point A. So I'm going to find RB by doing that. You can do the same method as I'm doing. Okay, let me rub this bit here out. Okay, go back a little bit. So I'm taking moments about point A. I'm finding RB. So start again. Pen. So moment is force times distance. Force times distance. I'm going to start with number 4 newtons times by 2 meters, because my 4 newtons is 2 meters away from point A. Okay, so it's 4 times 2. Is it going clockwise or anti-clockwise? Well, I think that 4 newtons, if you think about it, would make this beam spin that way, wouldn't it? If this wasn't here. In fact, the 4 is clockwise, the 6 is clockwise, the 9 is clockwise, and the 8 is clockwise. They're all trying to make this beam spin clockwise. The thing stopping it is this reaction B. That's going anti-clockwise. So anything clockwise is plus. So 4 times 2, the next one, plus, because we're adding them up. Sum of the moments, look, sum of the moments equals 0. What does that mean? The next one is 6. 6, and it's 4 meters away from my point A. So I'm going to do 6 times 4. Make sure you do to point A. Don't just, it's 6 times 4 there, look, because it's 4 meters away. Don't do 6 times 2. It's how far to this pivot point here. So 6 times 4 going clockwise. So I got plus. Next one is the 9, my UDL equivalent, and 9 is halfway, so it's 9 times by 5. 9 times by 5, going clockwise. So I'm going to do plus 9 times 5. 4, 6, and 9. Then the 8 is also going clockwise, isn't it? It would if it could. And how far is the 8 from my point A? It's 4, 5, 6, 7, 8. So I'm going to do plus 8 times 8. It's 8 meters away, and it's 8 newtons. That's 1, 2, 3, 4 forces. Going clockwise. The last one is this reaction here, because that is a force. We're trying to find it. Okay, so it's the force. Right, so I'll put in a different color. Right, I don't know what it is. How far away is it from my point? Well, this reaction is all the way along, and the beam is 10 meters long, isn't it? 2, 4, yeah, 10. So this RB is 10 meters away. So I'm going to times it by 10. Which way is it going to go? Well, this one is, this force here would try and make this beam spin that way, which is anti-clockwise. It's reacting against these forces. Okay, they're all going clockwise. This has got to go anti-clockwise, otherwise this thing will start to spin. So I'm going to put a minus. Let's go in the other way. 4 forces and a reaction. Okay, add them all up. Some of the moments have got to equal 0. I'm going to put 0 on the end. See if I can swap it. There we are. Equals 0. Now just add them up. So if you add up all of these numbers here, stick them in the calculator, put the brackets around it, you're going to get 141. 141 minus RB times by 10 equals 0. All I've done there is done 4 times 2 plus 6 times 4 plus 9 times 5 plus 8 times 8. That gives you 141. Okay, I don't like that minus thing, so all I'm going to do now is this. 141. I'm going to bring this minus RB times by 10 across. So I'm going to add it. So we get this, RB times by 10. Okay, All I've done is just moved it across. It's a minus there. Look, so to bring it across the other side, I'm just going to add it. So it comes across here, and then hopefully you can see that. So 141 divided by 10 will give me RB. I've left the RB there, that's times by 10, so I'm going to divide by 10. Which means that RB, I reckon, is 14.1 newtons. Lovely jubbly, everyone's a winner. Okay. So this reaction here, so RB is 14.1 newtons. Say RB, yeah. So I know that 14.1 is the reaction B. We've got to find now reaction A. Okay, you can do the same thing, but going the other way, you can go from that point there. But the quick way of doing it is this, because I know that RB is 14.1. I'm quite happy that it is 14.1. Because this beam is in balance, all right, this beam is in balance, so forces down has got to equal the forces up. Forces up. Okay, because the sum of the forces has got to equal 0. This beam is in balance, so what goes down must go up. Whatever's coming down, it's got to equal what's coming up. So I know the forces down are going to be the 4 plus the 6 plus the 9 plus the 8. Because that's the look, there, look. 4, 6, 8 and the 9. Look, 4, 6, 9, and 8. They're all coming down. That equals 27 newtons. All that means is there's 27 newtons coming down, which means there's got to be 27 newtons coming up for this thing to be in balance. We're in balance. It's not moving, it's just staying still. So there's 27 coming down, which means there's 27 coming up, which means RA plus RB has got to equal 27. So RA plus RB has got to equal 27. Okay. Because there's 27 coming down, which means for this beam to be in balance, there's got to be 27 coming up. Now, I already know that RB is 14.1. Okay, so I can say this now, can I? I can say that RA is going to be 27 take away 14.1. Because I know there's 27 coming down. I already know RB is 20, sorry. I know there's 27 coming down. I know RB is 14.1, so the difference has got to equal RA. So the reaction A is 12.9 newtons. And that's the answer. Because if I do 12.9 plus 14.1, I get 27. There's 27 coming down, there's 27 coming up. So this beam is in balance, everyone's a winner. The only thing wrong with that is, and you've got to be careful, that if my 14.1 was incorrect, then doing it this way, the mistake would knock on with it and make that 12.9 incorrect. So you need to make sure that you get your first one correct. I'm quite happy that that 14.1 is fine. Okay, so my RA reaction is 12.9. And my RB reaction is 14.1. Done. Okay. Happy days. So that's the same process. If you've got a beam with three forces on it and a UDL, we can just do what I've just done there. Look, you might have different numbers and different lengths, but it's the same process. Okay, so follow that and you should be all right. Make sure though that you get this first answer correct. Because doing it this way, you've got to make sure that your first answer is correct. Okay, what you should do really is take moments about point B as well. Over and out.